Good morning. Today we're going to talk about a few more characteristics of a quadratic function. If you recall from yesterday, a quadratic function is a function that is in the form ax squared plus bx plus c, and it forms what we call a parabola, which is really a U-shaped form, whether it's opening up or down. So a couple more characteristics. We have, and this is not highlighted, solutions, roots, zeros, and x-intercepts. All four of those words all mean the exact same thing. And it is where it is crossing the x-axis. So we always write our answers as an ordered pair. And if you recall, on a graph, if I'm crossing the x-axis, this is my x-axis and this is my y-axis. And these points right here are all on the x-axis. And if you think about the ordered pair, all points are written x comma y. But the unique part about an x-axis is that your y is 0. So all of these solutions or roots or zeros or x-intercepts, however you see it, is always going to be x comma 0. So wherever it's hitting the x-axis, but then it'll be a 0 in the y position. Now, the flip side of that, our y-intercept, is when it crosses the y-axis. And it's actually our c value when we see our equation written in standard form. So if you guys recall that ax squared plus bx plus c, this number right here that doesn't have an x with it, that is actually your y-intercept. So when we write it as an ordered pair, we would have 0 because it's a y-intercept, so x, you did not move in the x direction, and then whatever that c value is, that is your y-intercept. So let's look at a couple problems. We're going to kind of practice some things from yesterday as well. And for some reason, graph number 2 didn't show up, so I'll have to draw that. Okay, so the first graph number 1, our vertex. Well, our vertex, remember, is this point right here that's highlighted. So the ordered pair there would be negative 2 comma 5. Our y-intercept is going to be where it crosses the y-axis, which is right there. So that's at y equal to 1. So I'm going to write 0 comma 1. My AOS, if you guys recall from yesterday, is your axis of symmetry, and that's the x of the vertex. So that means my axis of symmetry is x equals negative 2. And then a maximum or a minimum, well, in this case, remember from yesterday, we have a high point because we're opening down, so I'm going to have a maximum, and that max value is always going to be, whether it's a maximum or a minimum, it's always the y of the vertex. So in that case, it's 5. Okay, our graph number 2, let me just sketch a graph here. It should, whoops. And okay, so that's kind of not very great of a graph, but we're just going to go with it. Okay, so our vertex is this point right here, which is the ordered pair 3, negative 1. Our roots, now remember our roots, which are also our x-intercepts or our solutions, that kind of stuff, it's where it crosses the x-axis. So it is crossing the x-axis, I'm going to make it orange, here at 2 and at 4. So we write this as an ordered pair. So it's going to be 2, 0 and at 4, 0. The y-intercept is going to be where it crosses the y-axis, which is that point, and if we count, that's up 7. So my y-intercept is when x is 0 and my y is 7. Your axis of symmetry, as a refresher, is our x of our vertex, so we're going to have x is equal to 3. And then this one is opening up, which means I have a minimum, and that minimum value is the y of the vertex, which in this case is negative 1. Let's look at a couple more. So this graph, we have a vertex, sitting right here. And that vertex is at the ordered pair -3, 2. Our zeros, notice, does this cross the x-axis at all? It does not. So we would just write none here. We do not have any zeros. Our y-intercept, it's going to cross. We got to be careful here and make sure we're counting correctly. It's actually falling between 6 and 7, so we're going to say it's at 6.5. So we're going to say it's 0, 6.5. Our axis of symmetry is our x of our vertex. So x is -3. This is opening up, which means I have a minimum, and my min is equal to the y of the vertex, which in this case is 2. And the last example. If we look, we have a vertex sitting right there, which is at 2, 5. So we have the vertex 2, 5. My y-intercept is going to be right down there, which is at -3. So since it's a y-intercept, it's when x is 0, and then we have it at -3. My axis of symmetry is the x of the vertex, so x is 2. And I'm opening down, which means I have a maximum, because that's a high point, and that max is at the y of the vertex, which in this case is